We're going to analyze this function by finding intercepts, listing zeros with multiplicities, determining whether we cross or touch the x-axis at the intercept, determining maximum number of turns, end behavior, and then tying it all together to sketch the graph. Okay, so remember, intercepts and zeros are just two different words for the same thing, at least in terms of x-intercepts. So there is also a y-intercept. Remember, y-intercept is found by putting in 0 for the x. And here, I could evaluate the rest of this, but notice I'm going to end up multiplying by 0, so this is just going to come out to be 0. Alright, for the x-intercepts, which again, that's the same thing as the zeros, we take the factors and set equal to 0. So here the factor is x, so automatically I've got that solution, x equals 0. My next factor is x minus 3. That gives me the x-intercept of 3. And my final factor is x plus 4, which has an x-intercept then at negative 4. And again, those are also the zeros. So let's put the multiplicity with each of them. The multiplicity is the exponent or the power that came from the corresponding factor. So the factor was x and it was squared, so this has multiplicity 2. For the next one, the factor was x minus 3. There's no exponent written, so it's understood to be 1. And for the last one, the exponent of x plus 4 is 2. It's the multiplicity that tells us whether the graph crosses or touches the x-axis. Even multiplicities only touch, and odd multiplicities will cross. Okay, so we've got these first few things found. Okay, maximum number of turns and end behavior. Both of those need the overall degree of the polynomial. The degree is the highest power of x when it's all been multiplied out. You don't want to multiply out the entire quantity. You can either just think about the highest power. So here we have an x squared times an x times another x squared. So x squared times an x times another x squared. That would give me an x to the 5th for my highest power of x. Or you can also look at adding together your multiplicities. 2 plus 1 is 3, plus another 2 is 5. And the multiplicities, notice they're coming exactly from the same idea of thinking about the highest power. So if the degree of the polynomial is 5, my max number of turns is always 1 less than the degree, which is 4. Last thing to find is the end behavior. Again, that comes from the degree, which is odd. So when we're talking about end behavior, we need to think about whether the degree is even or odd. And the other thing to look at with end behavior is the leading coefficient, the number that would be in front of x to the 5th. And you don't really need to know the number itself. Here it's pretty easy to see. It's just going to be 1. The key is that this is going to be positive. So you look at whether the degree is even or odd, and also whether the leading coefficient is negative or positive. An odd degree, like this one, means that the ends are going to go in opposite directions. With a positive leading coefficient, the ends go down on the left to negative infinity, and on the right they go to positive infinity. So this is the picture that I would like to see for your end behavior. Your textbook is just going to give a function, y equal 1 for the positive 1 coefficient, x to the 5th. But I don't think that tells you much about the graph. So this is what I would be expecting to see for your work on this. And you want to show it came from the degree and the leading coefficient. Okay, so then now we want to tie it all together for our graph. Before I put on the calculator, let's put on information that we found. We have a y-intercept at 0. We have an x-intercept at 0, which makes sense because that's the same point. We have an x-intercept at 3. and an x-intercept at -4. Those are the only 3 points that we have. But if I tie it together with my end behavior, so if it's going to have to come down on the left to -infinity, and then does something in between here, but on the right it then keeps going up to infinity. I have an idea of what happens at these ends. Now what about tying it together in the middle? Let's look here. At this x-intercept or 0 of -4, I'm going to only touch the x-axis. So it's going to come up from my end behavior, touch, and then it must turn back down. Now how low it goes, I have no idea, unless I plugged in some points. But I know that's the general shape that it's going to have to do. And then at some point it's going to have to turn back and come to this x-intercept at x equals 0, and again it's only going to touch the x-axis. So my end behavior, it'll touch, got to go back down, at some point come back up, again only touch, so turn back down, and then to get to this last x-intercept I'm going to have to come through again and this time cross through, and then that's how it's going to end. So I have a general idea of what this is going to look like. We are looking for the general pattern. So we're not worried about if you've made it go down as low as it should or anything like that. Now it should look like a function. I've got a little bump here in the table that I got caught in a groove. So let me try to make this, because you want to make sure that it passes the vertical line test. Okay? It should be smooth and not pointy. Alright, now this would be an acceptable graph because it's exhibiting everything that we've found from our information. If you want to look at it on the calculator, you certainly can. So it's x squared, x minus 3 times x plus 4 squared. And if we start on the standard window, zoom 6, it is not a great picture. Okay? Definitely you would not get full credit if you just copied this picture for your graph. Your graph should show everything that you found. To get a better window for this, we can manipulate with the window values. I'm not going down far enough because I'm not seeing these peaks down here for these minimums. So I need to go down lower. How low? I don't know. You try -50. Well, that's better, but I'm still not going down low enough. So I'm going to go back to the window. How about -100? And now I don't want to see a bunch of these tick marks, so I'm going to change my scale to be every 20 places. Aha, I see one of them, but not quite the other. It looks like I just got real lucky on guessing which one of these was lower than the other. That was purely a guess. And if this is -150, now will we be able to see what's going on here? Aha, there we go. So notice we've got the end behavior. You should have an arrow here. Comes up and touches, comes back down, smooth curve to come up and touch again. This one happens to go a little lower and then goes through. If your picture did not show this one going lower than that one, you would still get full credit because you're exhibiting all of the information that's been found.